Our group was assigned Lab 2. In this lab, we were given a truth table and we were supposed to create a Boolean equation and display that equation in circuit form. The easiest way to do this is to, where every output equals 1, we write down each of the terms. Taking that, we can then reduce the equation using K-maps and/or algebra theorems. When we fill out our K-map, we would use the midterm key and fill out each of the cells. Once finished, you would have a K-map similar to what's on the right here. Now, at this point, we would group our terms. We can group these together here and each of the corners together. After doing so, we can then take a reduced equation, f equals b naught and d naught, or c naught, and we can graph it like so using a circuit and logicism. But for this particular lab, we were supposed to use the integrated circuit models given to us in the library. Each one corresponds to a different gate, one to NOT, one to AND, and one to OR. Here's the NOT gate, here's the AND gate, and here's the OR gates. After we implement this, you should get something like this using our Boolean equation. The inside of each of those integrated circuits should look something like this. These should be powers and these should be grounds on each of the circuits. But there's also a second way to graph this equation using only AND gates. And you can do this also using just one of the AND gate integrated circuits. In conclusion, while completing this lab, we should have derived a Boolean equation using a truth table, reduced that Boolean equation by either using K-map and/or the application of Boolean theorems. Then, using our reduced Boolean equation, we created a representation using integrated circuits. The main takeaway from this lab should have been the use of integrated circuits and how they reduce components needed in any particular circuits. What were some of the things you learned?